Hello, we're going to talk about the intersection of two lines. Now, lines, they could end up intersecting, like I have this, this prism right here drawn, and you can see there's lines that do intersect, and they can intersect at particular points, right? But sometimes lines can, like if there's a line in this plane and this plane, we know that these two lines don't intersect, and these are what we call skew lines, so that can happen. So we're going to look at a few problems that looks at this. So the first one, it says, it's example 46. It says find, if possible, the coordinates of the points of intersection of this line, x is equal to 2y minus 1 is equal to z plus 3, and the line x minus 1 is equal to y plus 4 all over 3 equals z plus 2. So for this one, I can, if x is equal to this, if x is equal to 2y minus 1, I can just do some substitution. So I can have 2y minus 1 minus 1 if I take this guy right here and plug him into this x, and that's going to be equal to y plus 4 all over 3. And then this is going to be 2y minus 2 equals y plus 4 equals 3 over 3. And then I'll have 6y minus 6 equals y plus 4. And then I'll have 5y. If I subtract 1, 5y, and if I add 6, I get 10, so I get y is equal to 2. So I got y equals to 2. Now that I know what y is equal to 2, I can find my, well, first I can find my x, right? So x is x right here. If I put y into here, that's 4 minus 1. That's going to be 4 minus 1, and that's 3, right? So I know my x is 3. And now I can figure out my z. I guess would be the easiest one right here. And we found out 4 minus 1 is 3, and then I get 3 equals, well, I get 3 equals z plus 3, and my z is equal to 0. So I know that my point of intersection of this is the point 3, 2, and 0. So there isn't, these do end up intersecting. So let's look at this point 3, 2, 0 in space. Now B, it says given this, here we're given a vector equation of a line, right? Vector equation of a line, and then the line over here is x equals y equals z plus 3. This would be my x coordinate, so that'd be -1 plus lambda equals my y coordinate is 1 plus lambda, 1 plus lambda, and then my z is going to be -1 plus lambda plus 1, right? Which gives me -1 plus lambda equals 1 plus lambda equals, this would be just lambda, right? And look what happens. I can subtract lambda out of all of this, and I get -1 equals -1 equals 1 equals 0, and these obviously don't work. So these are just skew lines, because this is a contradiction. This can't happen. So these two lines, they don't intersect, right? Now moving on, we can also have the intersection of two planes, right? Two planes when they intersect, well, you could think of it as two planes that sometimes I like to talk about in the corner, right? Sometimes, well, if you look at the corner, two planes, they could be parallel and not intersect at all, but they can, when they intersect two planes, like when you look at the corner, right, they intersect at a line. So that's what we're going to find out in this one. So it says, going to say find the intersection. It says in the form, we want to write it in this form, the intersection of this line in this form right here. Find the intersection of the planes. Hence, state the coordinates of the point of the line and the components of the vector parallel to the line of intersection, right? So first let's find out, and if you look at this one, it's pretty simple. I can just add these two. I have equations of planes here. I can add them together, and look what I get. I get 3x plus y equals 1, right? So that means I know that x is equal to -y plus 1 all over 3, because I want to write it in this form, or better yet, I would write that as y minus 1 over -3, right? So that's what that would equal. Now I can just, well, you could try to eliminate again, but I kind of like being able to just to substitute in, and I can easily change this equation to y is equal to a negative 3x plus 1, and then I can plug y into that top equation up there. So I can say, well, that's 2x, right, minus my y is negative 3x plus 1 plus z is equal to 1, and then I'm going to have I'm going to have 5x, right? I'm going to have 5x minus 1 plus z equals 1. Add 1, I'm going to have 2, right? So I have 5x is equal to, get a little more space here. So I got 5x is equal to, I got negative z, looks like we're going to have plus 2, then divide by 5, and x is equal to, I want to write this as z minus 2 over negative 5. So finally, what do I have, right? I know that I can write x is x minus 0 over 1, because x is equal to this. My y is y minus 1 over negative 3, right? And then my z minus 2 over negative 5 over negative 5, right? And it wanted me to write the vector equation of this on line 2, and I can do that. Or what its components, these give me my points, right? So I can write my vector equation r, right? My vector equation goes through the point 0, 1, 2, and has the vector 1, negative 3 and negative 5 right here, and these are my components of the vector equation of the line through that is the intersection point of the two planes. Sound good, guys? Good, thanks.